Lesson 1.18, continuity, we're finding k. Directions say to find the value or values of k that make the function continuous. Okay, so right now I put this on my phone where I have the first function, the negative 12x plus 120, only for x values greater than 6, and then something times x minus 6 for x values less than or equal to negative 6. Or 6, sorry. So you see that there's a break right here where x is 6. Our job is to try to figure out what could k be, or what would it have to be to make this graph be continuous. So what's kind of neat is on Desmos you can use a slider button and you can see by changing k what it does to our function. So it's like a game. We want to get our pieces to match. Somewhere in there. Okay, it looks like it's saying that it would be a 9. Let's check how to do that mathematically. So when we're trying to think, how do I get it continuous, or the pieces of a piecewise to be continuous? Well, we want the limits from the left and the right to match. And when we were doing limits, we were plugging them in. So think we want the limit as x approaches 6 from the left of f of x to equal the limit as x approaches 6 from the right of f of x. So my left-handed one would be this one right here. This x is less than or equal to 6. I'm going to plug 6 in for x. So it would be a 6k minus 6. And then I'm going to equal it to the right-handed limit, which I could find by plugging 6 into this one. Negative 12 times 6 plus 120. Negative 12 times 6, isn't that 72? Yep. And we solve it like a normal equation. So I would combine this 120 and negative 72, which is 48. Add 6 to both sides, which is 54, and 54 divided by 6 makes k equal 9, just like we showed on Desmos. All right, number 2 is going to be that same thing. I'm not going to set up the limit part of it. I'm just going to set each piece equal to each other, and I'm going to plug in 3 for x. So I'm going to have k squared minus 18 times 3 equals a 3k. 18 times 3 is what, 54? Yep. Yep, and you should remember that when we solve a quadratic, we're going to get most likely 2 answers, and we need to have it set equal to 0 before we do anything else. So I'm going to move the 3k over. What 2 numbers multiply to make negative 54 and add to make negative 3? Wouldn't that be a negative 9 and a positive 6? So k equals 9. K equals negative 6. So you actually get 2 k values that would work in this case. Okay, we got 2 more, and they are rational functions. And when we have a rational function, we first want to factor them because we need to see if there's a whole, or we need to see if there's a vertical asymptote. So you might want to put a note. We'll put factor first, check for wholes or asymptotes. So let's factor the top. What 2 numbers multiply to make a positive 6? That would be, we need 2 negatives, that would be negative 3 and 2. And then on the bottom, we need 2 things that multiply to make a positive 18. So that would be, what, negative 6 and negative 3. So I do see a factor that cancels. And if you remember back from last year when we had a factor that cancels, that means there's a hole at the solution of that factor. So there's a hole at x equals 3, which happens to be why they said x can't be 3. That's what's going to make it a function is something has to plug the hole in at 3. So now our function is really x minus 2 over x minus 6. So let's think about this. If this would be continuous, because there's no asymptotes other than at 6, which this is not the problem, there's a hole at 3, and we need to find just some value of k at 3. There's no like greater than, less than, it's just something specifically at 3. We just plug in 3 and figure out what value is going to plug the hole at 3. So we would have 3 minus 2 over 3 minus 6, which is 1 over negative 3. So at negative 1/3, if that was our y value, that would plug in the hole here and make it continuous for that interval. Kind of neat. All right, number 4, go ahead and factor the rational expression. Let's see what's going on. Should have gotten that x plus 7's cancel. So there's a hole at negative 7, but that's not an issue because now they're wanting us to look at where x is negative 1. No other range, just right at x equals negative 1. So I write what the function is now, which is x plus 4 over x plus 1. The denominator is always the issue. What can't x be so that we don't get a vertical asymptote? Well, it can't be negative 1. So I said that kind of weird. There's a vertical asymptote at x equals negative 1. And that happens to be where they're wanting us to check. So if I plug in negative 1, is that ever going to help a vertical asymptote? No. So there's nothing I can possibly do to fix a vertical asymptote. So there is, I don't know if it's undefined, or I think you're just going to give like these blank brackets to say that there's like no solution for these. Okay, so again, rational functions, you have to factor first, see if a factor cancels. If it does, that means a hole exists there. If you're trying to figure out your what makes it continuous at the hole, then you're just plugging your x value in to your simplified function, and that'll be your k value. If you factor and you figure out that it's got a vertical asymptote at where they're wanting you to fill the spot to make it continuous, then that's never going to be possible. That's no solution.